Okay, everybody, we're going to start up again. So, I just wanted to review some important, we're still kind of reviewing some of the basics of WMS, and I wanted to talk about images and projections. Just give an overview of some of the images and projections in WMS. And so that's what we're going to talk about. We're going to talk about images, how I can get images into WMS, and also about how to project between different types of data. So you have several different kinds of data, that several different projections that you can be working with. And I don't know, what projection do you use in Egypt? Does anybody know what projection? Yeah.
There are two projections. One WGS 84.
Okay. Zone 36.
There's another one which is local, designed by some engineers, surveyors. It's called the blue belt, the red belt, and the yellow belt.
The blue belt.
Yes, that local one has divided Egypt into three longitudinal zones.
Okay. Okay. Well, we'll see if WMS supports those projections. I know that it does support the UTM, the WGS 83, 84 coordinate system, zone 36. It supports that for sure, but I'm not sure about the other one. So, when I talk about an image, what is an image? So I'm going to ask you guys, what's an image? Yeah, it's just a picture. And so I saw Ahmed taking a picture over here. Were you taking a picture? So it's just... Yeah. Right. So it's just a 2D grid, right, of colors. And each of those grid cells is called a pixel. Pixel is what we call it, which stands for picture element. And so that's what an image is, just a bunch of cells with a color for each cell. And it can be used for a lot of different things. Most of the time you're going to use, if you have a picture, you're just going to use the picture as a base map for your watershed model. And you can't extract any data from an image. Really the only thing you can get from it is just the background information, where the roads are located, where your rivers are, and maybe the land use type. But they're really useful for locating things. And if you have a whole bunch of pixels, that means that you have more detail, but it could bog down your computer. If you have a huge image, then that could end up bogging down your computer. Also, if I download the higher resolution image, if I download a higher resolution image, it's going to take longer to download that, especially here where your internet connection is slow. And there are several different formats of images. Some formats are TIFF, JPEG, and Mr. SID. Mr. SID is a certain kind. What's that?
Satellite images.
Yeah.
We have downloaded many of these satellite photos for the Earth.
Yeah. So there are a lot of different formats for images. And to get images into WMS, you have to register the image. You want to register the image. And by registering, what I'm referring to is you define where that image is located in the whatever coordinate system you're using. And so the way you register an image is you define 3 points. And for each of those points, you define an XY coordinate. And the XY coordinate could be latitude and longitude, or it could be, if you're using some XY coordinate system, it could just be an X and a Y value. So you define the 3 points and you define a XY coordinate. There are several ways of registering images, of doing those 3 points and then registering the image. One way is if I just download the image from WMS, like you saw here. Let's go back here to WMS. So here in WMS, I downloaded this image from an online data source, and that's just downloading an image, and that image is already registered. Okay. Another way is if I have something called a GeoTIFF. That's a TIFF file with the registration information inside of the file. That's called a GeoTIFF. And if I have a GeoTIFF, then WMS will automatically register that image. I don't need to do anything. I just read it in and it'll be registered. Another thing that I can have is something called a world file. And a world file is a file with that just has the information about the registration inside of the file. And it's a separate file. It's not included in the TIFF file or whatever file you're reading in. Another way to register an image is you can just manually register the image. So let's talk about some of these things. This is a world file. And a world file is just a text file with 6 lines, and these are what the lines mean. So you have your pixel size in X, rotation term, pixel size in Y, and then the upper left coordinate. That's a world file. And if you have a world file, then your image will be registered. So if I have, for example, a JPEG image, so a file that ends in .jpg, or a TIFF file, then you can have a world file that goes with the JPEG or the TIFF. And usually the world file will have an extension like JGW for a JPEG, or for a TIFF you had TFW. There'll be .tfw or .jgw. And that's your world file. And this is what the world file format is. Just 6 lines, ASCII format that has this information. That's your world file. To manually register an image, you define 3 points, and for each of those points you define an XY coordinate. And this is the window that comes up in WMS if the image is not registered. You'll define these 3 point locations and then define an X and Y value. There are a lot of places to get images, and one place is the online image, downloading online images from WMS. And if you download images online, then you don't need to worry about registering them. Another option for Egypt is if you have a paper map, you can scan that map in and then manually register that image. And that's a little bit hard to do, but it's an option you have. So this is the Get Online Data tool. And I've shown you how to use that, but you just go here to WMS. If I want to get an image for this area here, I can go to Get Data from Map, and then it'll bring up the area where I am. Hit OK, and then you just select whatever type of data you want. So let's say that I want maybe a world street map for this area. I can select that. We'll call this Sinai, and then I'll just save that out. Okay, so that's get online maps. Let's see here. It's going to ask me for a resolution. I'll let that download and we can look at it later. In the US, you have different kinds of maps. We're not going to talk about these, but The U.S. actually has these topographic maps they're called quadrangles, for different areas of the U.S., and you can download these online. Do you have something similar to this in Egypt that maybe you can download? You guys know? You have contour maps like this. They're just paper maps, but they're not digital.
Not available. We buy, we purchase them, and we scan them.
Okay. So probably the best data sources are just the online data sources from WMS, or if you have something, if you save something from ArcGIS or something, you can use that. Okay, you can also, you have aerial photographs. So if you're bringing in a scanned image, you can just use a desktop scanner and save that file as either a JPEG or a TIFF file, or actually that you can save it basically in any format. And WMS will read that in, and then you have to register that, and you define the 3 points and register it. When you're done registering the image, you'll want to save a world file. So either a TIFF, if you're saving it as a TIFF file, you'll save a TIFF world file, or if it's a JPEG, you'll save a JPEG world file. Okay, so let's talk about projections. The other part that kind of goes with images is the image has to have a projection. And by projection, I'm referring to there are thousands of different projections that people have defined. And what you're doing with a projection is you're taking, since the Earth is, you can approximate the Earth as a sphere or an ellipse. But to do watershed modeling or to do hydraulic modeling, you have to define some kind of projection, an XY projection. The reason you have to do that is to compute lengths and areas. And so this is an example of a projection. Projection is just like what you've learned in geometry. It's just an XY coordinate system. And the surface of the Earth is something like this. It could be a mound or a mountain. You approximate the surface of the Earth with an ellipse, and then you project that surface onto a plane called a projection plane, and that's a projection. And so to do watershed modeling, you can't use latitude, longitude, or geographic coordinates. To do watershed modeling, you have to use an XY coordinate system. Some of the most commonly used XY coordinate systems, well, one of the most commonly used ones is the Universal Transverse Mercator coordinate system. And this is it's also, we call it the UTM coordinate system. These are the UTM zones in the United States. Egypt, let's go and see if we can find the Egypt. So if I go to XMS Wiki, that's the WMS help site, you can just search for UTM. So UTM, that stands for Universal Transverse Mercator. That's the UTM coordinate system. And I can click on this first thing that comes up. So these are the US UTM zones. You can also look at the world UTM zones. So here's the map of the world, and it looks like, let me click on this map, we'll bring it up. So it's kind of not very good. It's kind of a little bit hard to see, but Egypt, it looks like, is in zone 36. If you're in Western Egypt, maybe that's 35. Okay, so 35 or 36 if you're in Egypt. So that's the UTM zone. That's the world is broken up into different zones, and each zone is 6 degrees across. So in total there's 60 UTM zones in the world. And the US uses the state plane, but you're not going to use this. These are kind of like local coordinate systems in the US. Okay, so let's say you have data in different projections. If you have data in different projections, then you might have to get those in the same projection. Yeah. So if you have data in different projections, then you might end up with something that looks like this. So so in this image, this has some elevation data, and I've computed streams from my elevation data. So these blue cells here, those are the computed streams. But here's a line that you see on this topographic map. So these are topographic contour. This is a topographic map, and the green is kind of forest area. This red is a road. This blue line is where the stream should be. Okay, but I've computed the stream up here. That's because I have my data is in different coordinate systems. I need to get all my data into the same coordinate system. If I do that, then here's what I end up with. So the stream, the computed stream, that's these blocks here, those are closer to the actual stream location. So everything is just lined up, yeah. Okay. There we go. Another thing you could end up with is maybe you have data that's in UTM coordinates, and then maybe I have another set of data that's in the local Egypt coordinates, and I need to get all those in the same coordinates. And maybe I have another data set that's in geographic, which is latitude, longitude coordinates. I just need to get everything in the same projection. And so what you do is you decide what projection you're going to use, and you can either convert all of your data to that projection, or when you bring it into WMS, WMS is going to automatically convert it if the projection is defined. If WMS can't figure out the projection though, then you'll have to manually convert the data. And I'll show you how you do some of that stuff. So it's important that whenever you start a model that you have to know what projection you're working in. Otherwise everything won't line up. And for example, let's go back here to WMS. So here in WMS, I've downloaded all this data, and when I downloaded the data, WMS set a default. It set its own coordinate system. And when I download data using this get data from map, the projection and coordinate system, whenever I refer to either of those, that's the same thing. So projection is the same as a coordinate system. But when I download the data, the projection that WMS uses, if I go to display and select display projection, WMS is going to automatically set my projection to UTM, since UTM is for anywhere in the world. And then it's going to set it to whatever zone that I'm working in. So in this case, I'm working on the Sinai, which is in UTM zone 36. So it set my projection to UTM zone 36. I probably want to set my datum to WGS 84, which is the same as NAD 83. NAD, it stands for North American Datum, WGS stands for World Geographic System or something like that. It's worldwide system. And WGS 84 is the most recent. And so that's the datum that I'm working in. And so that's WMS is going to default it to that projection. And so all this data is in that projection. If I wanted to reproject this data, I could go to Edit menu and select Reproject. And right now I'm in this UTM zone 36. I can change that to any of these. I can change my data to any of these projections that WMS supports. So what was the projection that you use in Egypt? What's it called? Okay, you use UTM. The data is in UTM, but there's a local projection that you geographic. So you could use geographic, but we can't do with geographic. That's latitude and longitude. So we cannot compute areas if we have that. I think I'm referring. Okay. So it's called Egyptian Transverse Mercator. So maybe it's Transverse Mercator. Let's go to that. And then the datum maybe is Egypt. Let's see if we have that. So Egypt, I don't know. Maybe this one right here. Try that. And then you'd have to define these, the central meridian and all this stuff. Yeah, you could load it, or you could define it and then save it out to a file and then load it in. But anyway, so you can define all of that. I'm not gonna do that, but maybe we can look at that a little more later and try to figure that out. Did you have something? Okay. All right. So that's how you, if I need to reproject my data, if I need to convert my projection for everything, I go to Edit, select Reproject, and this is going to reproject everything that I have in WMS. Also, each set of data in WMS has its own projection. So if I right-click on a data set, you can go to Projection and define a projection for each set of data. Right now, all my data is going to be set to UTM zone 36 because that's what I downloaded it in. But I can change that if it's in a different projection. If I change that, WMS will display it in the display projection. And the display projection you set right here. So you go to Display and select Display Projection. So if I want to display this data in maybe UTM zone 35, I can set my display projection to zone 35, and the data will be displayed in zone 35, but there's some data that WMS does not automatically reproject. It doesn't change the display automatically. And so what's that? Oh. That's okay. Are you having a hard time seeing the screen? Is that? Do you have a hard time seeing it? Okay. Okay. So if you want to reproject everything, let's say I wanted to reproject everything, I can just set this to zone 35. Let's say I wanted to reproject this to zone 35. I can do that. The problem is when you reproject, you have to recompute your basin data after you reproject. And you also have to rerun, and we'll talk about this later, but you reproject and then everything kind of tilt. Did you see that, how it tilted? That's because it's in a different projection. Then my coordinates, so down here at the bottom of your screen, this is your X and Y coordinates in your current projection. These coordinates here, these are your latitude and longitude coordinates. So as I move my cursor over the screen, I have my X and Y and latitude and longitude. In some of the modules, like this terrain data module, WMS will also, as I move my cursor over the screen, you'll see a Z value right here. So down here at the bottom, so right here at the bottom, I see X, Y, and then the Z value. Okay, and it'll show me my Z value if I have a Z value. So right here, but I can't show it to you unless I'm on it. So that's the Z value. Okay, so that's so we talked about reprojecting. So your projection is really important. You have to decide what projection you're going to use. It's going to be used for the measure tool. There's something called the measure tool, which is this tool up here. If I measure distances, like if I want to measure like how long this watershed is or something, then down here at the bottom of the WMS screen, it has the distance and the slope of that line that I created. And so it's just displayed in red down here at the bottom of the screen. So that's the measure tool. It's also used when I compute my basin data. So my watershed and stream geometric data. It's also used to compute the length of my feature object. So if I go here and select a stream or something in my drainage coverage, so let's go here, select one of these lines. WMS gives me this feature arc length. That's the length of that stream. That's computed using my my units right here. My current projection. So it's used for a lot of stuff. So are there any questions about projections or images? Do you know how to get images into WMS now? Okay, you probably just use the get data from map. That's a good way to get an image. Another thing, let me show you. I think I have some data here on the disk drive. So I'm gonna put this data on the local hard drive here. Okay, so here I have some TIFF files. Let's read in some of these files. These are just, looks like I have some images and a street map. This is for the Nile Delta. I've just downloaded these images. So I can just read in, if I have a TIFF file, I can read in a TIFF file. And so here's that file. Here's Cairo, the roads and stuff. I could also read in this image here. And this is just an aerial photograph of the same area. And so when I read in an image, you'll see over here, these are the images under GIS data. So they read in under the GIS module. This is called the GIS module. And under the GIS data folder, I have these two images. I could turn these off, and they're just layers under the GIS data folder. And there are different options. I can export this image to a different format. I can also export a world file, which is like a TIFF world file for this image. Since these images they're called GeoTIFFs, they already have their registration information. I just read them in and they're automatically registered. If I needed to register this image, I can, when I read it in, it will bring up this window, this register image window. And then in this window, I would define 3 points. So I can move these points around, define these points. Let's see. Where's point 2?
It's up to the right one.
Oh, I see it. Okay, here we go. So I define 3 points. Oops. I'm having trouble with that. Anyway, you could, oh, here we go. So usually you'll define them in some kind of square like this, and then for each of those points you would define the X and Y coordinate. That could be latitude, longitude, or it could be whatever local coordinate system you're using, or it could be UTM or whatever. So if, for example, if you scan a map, it would bring it up in that, and then you would define those coordinates. Another thing, so I just wanted to mention there are different types of data that you can have in WMS. Any GIS file, almost any GIS file, you can read in under this GIS data folder. If I want to read in a GIS file, I'll go to this Add GIS Data button, and if I select that button, you can read in pretty much any kind of GIS data. So one of the types of GIS data is called a shape file. Let me read in this shape file. We'll see what it looks like. This is a big one. So it takes a long time to read. Let's see what the projection, okay. I think I need to set the projection for this shape file. I'll just frame. Okay, so this shapefile, it has it's a large database that has land use for, this is actually Greece up here, and then this is, I think, Turkey, maybe. And then this is kind of northern Egypt. So it just has different land use types. I have another file that has the Nile Delta land uses. What's that?
Okay, everybody.
I think it finished. Okay. Anyway, so these are the different land use types. There's a lot of them. And it's just a shapefile. You could read in a lot of different types of data. Another type of data you could read is an elevation data set. So this is the elevation data. Whoops. Just want to zoom into this. So there's the elevation data for a lot of the Nile River Delta. And this is just the SRTM data. The resolution, if you go over here, the resolution is really low. I guess it's 182 meter cell size, but you could download better resolution if you want. So that's these are different, we call them images, but some of these aren't images, but we're kind of talking about GIS data. So these two things would be images. I could turn these layers off. This is an image, this is an image. This would be elevation data. And you can convert each of these types of data to different data that you can then use in WMS. So to actually use the data, I'd have to convert it to the right module and then be able to use it in WMS. So like, for example, this elevation data, I can right click on this and convert that to a DEM. That'll put it in the terrain data. Let's go ahead and do that. That saves out a file and it converts it to a DEM. So now I have this DEM under terrain data. And that's what I wanted to talk about next, actually, is DEMs. So let's talk about DEMs. Actually, before we talk about DEMs, let's talk about feature objects. And I've already mentioned some of these things. So there's a term we call feature objects. Feature objects, the definition of feature objects is feature objects are GIS or vector-based GIS data in the map module of WMS. So whenever I refer to feature objects, I'm talking about vector-based GIS data in the map module. And there are two types of GIS data you have. One type is raster. Anyway, what's raster data? What's that?
It's like an image.
Yeah, an image would be.
Like a grid data.
Yeah, it's
which has a
gridded.
certain value.
Right. So grid-based data. So it's like a two-dimensional grid of data that has a value for each grid cell. So an image would be raster GIS data. Another raster GIS data would be like elevation data. Elevation data could be raster GIS data, like an elevation grid. You could also have land use grids, and land use grids are raster GIS data. So any two-dimensional grid of data, that's a raster in GIS. What's a vector? What's vector GIS data? What about vector? Anybody tell me what that is? Yeah, so points, lines, and polygons are vector. Okay, and any of that data you can bring into the GIS modules. You can bring in raster or vector GIS data into the GIS module of WMS, but then we have to convert that data to another module to actually be able to use it in WMS. So what we're going to, there's the GIS module, and then there are other modules in WMS. The main module where you work with vector-based GIS data, that's the map module. And data, vector-based GIS data that's in the map module, that's called feature objects. And feature objects are vector-based GIS data in the map module with attributes. They have attributes. We're going to learn how to create feature objects and use different ways of getting feature objects, how to convert GIS data to feature objects, things like that. And so the GIS module is the kind of the center for GIS data in WMS. So vector and raster GIS data is all in the GIS module. This has kind of changed actually over the years. So it used to be that we would put images in the map module. So if you've used an older version of WMS, images were in the map module. Now images, any raster GIS data is going to be in the GIS module. And so the GIS module is the center for GIS data in WMS. The map module is vector-based GIS data that can be used for watershed modeling in WMS. And there are lots of different, so we've already talked about raster. These are rasters. This is a DEM. This is a topo map, a topographic map. That's a raster. Okay. We'll have to. I'll help you with. Oh, you are connected. It could be that I don't know what's happening, but we'll figure it out. Okay. Do you want to get it working right now, or do you want to do it later? Let's wait, and we can do it later. Is that okay? We'll do it next break. What time is it right now? What time do we break for lunch? 12 o'clock. Okay. We'll have another short break before then, probably at 11 o'clock. We'll just take a short 5-minute break. And we'll look at that then. So, vector data are points, lines, and polygons. So we already talked about the difference between raster and vector data. So what's the difference between CAD, just regular CAD data, and GIS data? What's the difference? Yeah. Okay. So there are a couple of differences, right? So one difference is that you say there's the CAD data does not have attributes necessarily, or it could have attributes, but usually it doesn't. You don't have attributes. Whereas GIS data, you can have, like this polygon here has a bunch of attributes associated with it. And then another thing is GIS data, you define a projection for GIS data layers, whereas CAD data, usually you're not worried so much about projections. Yeah. So DXF doesn't have a projection defined usually. I don't know the specifics of DXF, but I don't think you can define a projection in a DXF. Oh, is there a way?
It's only dealing with the projected data. So it's like you can project into the CAD system. You can export from ArcGIS.
DXF, and then you can open it in the drawer.
Okay.
So you can keep the projection.
Okay.
But if you move it in CAD system, it would be still with it. So that
It
the
kind
video
of-
will be destroyed.
Okay. So the projection isn't, the CAD doesn't really know about projections, different coordinate systems, but and it also doesn't have the attributes. So those are kind of the differences between CAD and GIS. So GIS actually has attributes, it has projections defined. And how things are connected is really important in GISs and especially in WMS. And it's really important because for WMS to create a hydrologic model, it has to know the directions of flow, the direction the water is flowing. It also has to know how the basins are connected to each other. So connectivity is important. The line being adjacent to each other is important, and then the directions of lines is important. So if I were to zoom into some lines here, if these lines aren't connected in exactly the right location, then I could have problems. And the computer doesn't know that these lines are all supposed to be together. And each line in a GIS has a direction. And this is especially important in WMS. Each line has a direction. You have to know your direction, your line directions. WMS has several different kinds of coverages you can use, and these are some of the different kinds of coverages. And the main coverage that you're going to use for watershed modeling is called the drainage coverage. When I delineate a basin, so let's go back here to WMS. Let's just delineate some watershed here. So when I first start up WMS, or when I delineate a watershed, WMS is going to create something called a drainage coverage. So this is my map data, these are my coverages, and under my coverages, when I first start up WMS, it has a drainage coverage. And the drainage coverage is kind of the center for any watershed modeling in WMS. And I'm just going to change a couple things here and create a watershed model. So here in the drainage coverage, this is where all my drainage data is defined. And this this drainage coverage, it has points, and the points are used to represent outlet locations. It has arcs. So let's see, I have this select point tool. Here's my outlet right here. That's points. You can also represent different attributes with points. If I double click on a node, I can define attributes. Arcs are used to represent my streams. So these are my streams here. Those are defined by arcs, and you can have these different types of arcs. But in general, arcs are either used to represent streams or a basin boundary in a drainage coverage. And then polygons. And I can select this select polygon tool. And polygons are usually used to represent my basin boundary. So here's my polygon. It represents my basin boundary. Arcs have a direction, and I can turn on the direction of the stream arcs. If I go to the display option, I can turn on my stream arrows, and you'll see the stream direction. So these stream arrows show me the direction of flow. Let me turn off some of this stuff. So you can see that all the streams are going downstream. So those are my arcs. So that's a drainage coverage. That's the center for all of my watershed modeling in WMS. It's in the drainage coverage. You can actually have more than one drainage coverage, and usually I would recommend just having one drainage coverage and just defining all of your data there. So that's the drainage coverage. You can have all these other types of coverages. I should mention that one commonly used GIS vector-based GIS format is called a shape file. And a shape file is not just a single file, it's actually 3 or more files that have vector-based GIS data. The file that ends in .shp, that's it has your geometric data. So it has your points, arcs, or polygon data. There's a file that ends in dbf that has your table data, so your information, and then a shx file relates those two files together. WMS is always looking for the shape file, but you have to have all 3 of those files. Sometimes you'll have something called a projection file that goes with the shape file, and that will have your projection information. And there could be other files that go with the shape file, but you read those files into the GIS module. And if you have ArcGIS on your computer, do you guys have ArcGIS here? You do? Some people do. If you have ArcGIS and you're using the 32-bit version of WMS, you could enable ArcObjects. And ArcObjects will allow you to read anything that ArcGIS can read. But most of the time you're not going to even need it, because WMS will actually read pretty much any format anyway. So just through the GIS module. So WMS feature objects, you have points, arcs, and polygons. So a point is just a point that's an XY location that's by itself. It's not connected to any arcs. A node is a point that is connected to an arc. And an arc is a polyline that has a node on each end and has 0 or any number of vertices. So it could have 0 or 5 or 10 or however many vertices you want. That's an arc. The difference between a node and a vertex is a node can have attributes, so you can define an outlet at a node location, but a vertex cannot have any attributes. A polygon is a closed set of arcs. And so, for example, I already showed you a drainage coverage. In drainage coverage, you have points, arcs, and polygons. The points are the outlets, the arcs are the streams, the polygons are your drainage boundaries. You can have other types of coverages. You can have a generic coverage that doesn't have any attributes. You can have a drainage coverage. We've already looked at that. You can have a land use coverage that has polygon attributes. You can have a soil type coverage that has polygon attributes. A runoff coefficient coverage, this is used in the rational method, and in that coverage you define a rational runoff coefficient for different polygons. A time computation coverage, which has arcs that have formulas that are assigned to each arc they're used to compute the time concentration. NSS region coverage, this is only used in the United States, and it's a statistical method NSS is a statistical method that has equations for each state in the United States, and it's but they're only useful for the United States. So you can have a 1D hydraulic cross-section coverage where you define cross-section arcs. This is used in HEC-RAS modeling. We're going to talk about that later in the course. And you can cut these cross-sections, and you can look at the cross-sections and then edit the cross-sections right here. You can have a 1D hydraulic centerline coverage, and in that coverage you define the stream center line. So this is a stream center line, and you also define bank locations. An area property coverage, which is used for hydraulic modeling also. You define different Manning's roughness values for polygons. And the map module is used for all of your modeling in WMS. So to get data, to do any modeling, you have to convert your data to the map module. And that's feature objects. So you convert it to GIS vector data in the map module. That's feature objects. Convert to feature objects in WMS. And it's different from the GIS module. If you bring it in the GIS module, you cannot use it for modeling usually. It's just used as a background map. But to convert between the modules is not that hard. There are easy ways of doing that, and I'll show you some of those ways. Creating feature objects in WMS, one way of doing it is just to, if you have a background map, you can create your feature objects. That's called digitizing, pointing and clicking, creating data. It's called digitizing. You can digitize your data. Another way is you can import shape files or any GIS vector data, or you could import CAD data, so DWG, DXF, and DGN files. That's just CAD, different CAD formats that can be imported into WMS. Okay, some rules for creating feature objects. You have to use the create tools. Anyway, they're just different rules, and maybe I'm going to review these rules just in a demonstration. Let's go back here to WMS and we'll look at some of these rules. So let's say, for example, that I wanted to create a stream in WMS. If you're doing hydrology in WMS, it's different for hydraulics, but if you're doing hydrology, then you would create a stream from downstream to upstream. You always create your streams from downstream to upstream if you're manually creating streams. So here I already have some streams. Let's say I have some other stream. I know there's some other stream in this watershed and I want to create that stream. So what I could do, let me zoom in here. I select the create tool. Remember, create tool doesn't have an arrow on it. So any tool without an arrow, if I select that and then click in the graphics window here, then I'm creating something. So I'll select the create arc tool. Yeah.
You can see two very close parallel stream lines. In reality, of course, according to what I said before, it's only one stream.
Right.
So is there a way to guide the WS what pixels and what areas to?
Yeah, and really, my flow. We're going to talk about that later. Actually,
there is a way to push it to consider only one stream. For example, don't make two streams in distance less than 100 feet.
Mm-hmm. Yeah. Yeah, and we'll talk about that later in the course. But there's something called a flow accumulation threshold, and I'll show you how to change that. But let's say I wanted to add a stream in here. I can select this tool and just click close to one of the existing streams. So if I click close, WMS will snap to that stream. So it snaps to this stream, and then I can just draw in my stream wherever it's going. Okay. And right now my current attribute is not set to be a stream attribute. So what I need to do is change the attribute of this stream so I can select this stream. So I select this select feature arc tool, and that's the one with the arrow on it. So any tool with an arrow is a selection. So I select this, and I can right click on it, or I can go to feature objects, and if I right click on this, there's a menu that comes up, and I can go to the attributes, and I can just change that to a stream. Okay, and so now that's a stream, and you can see the arrow is going downstream, so it's in the right direction.
Because we started from this point, this down
I started at the downstream end and went upstream, and for hydrology that's what you have to do. So if I do the opposite, if I start at the upstream end and go downstream, let's see what happens. Okay, I get an error. Multiple downstream segments encountered. It's just going to convert it to, I can't convert that to a stream unless there is an option actually to reverse the directions. If I select that and then reverse, there's a reverse directions command right here. Select that. I have to do it again because I've done it 3 times. Then I can convert that to a stream and we're okay. Alright. Another thing about creating feature objects is if I don't get close enough to an existing arc, so if I click right here and I create a stream, then WMS is not automatically going to snap to this arc. So if I zoom in here, you can see that this point is not connected to this arc. So WMS will not automatically snap. And so I just need to make sure I get close enough. There is a way to snap to that, and that's using the clean tool. So I can select this and then right click and select clean, and then I can snap it to a node. So then it says down here select a snapping point. So let's just select a node on this stream. Let's select like that node, and then it'll snap it to that node. But everything has to be connected. If it's not connected, then WMS will not know that it's connected. Okay, if I don't get close enough, if it's not connected exactly. Yeah, do you have a question? You're wondering if WMS will consider this stream now that I have it snapped? Yeah, it will. It'll use this stream.
So I need to calculate the basin data after I create some streams.
Okay. Yeah, so I added some streams in. And since I did add some streams, I would probably want, yes, I would want to recompute the basin data. So I could do that. And you could just go here to compute basin data again. And you'll get an error message because I added some additional streams in. And it changes the flow in my watershed. We're going to talk about this a little bit later. But when I add streams into a hydrologic model, it changes the way the flow happens in my watershed. And so actually I have to redefine my watershed as well as recompute my basin data. So there's some things I have to do. But yeah. Uh-huh. The flow direction. Yeah. You're saying you use it to change, you use the streams to change the flow direction?
Change the flow direction before.
Uh-huh.
Then I delete the basin.
Oh yeah, right. Okay. And that's what streams do. They actually do change the flow direction on the DEM. And we're going to talk about that later, but it's, anyway. So the other thing that I wanted to mention is there are different coverage types you can have in WMS. One of the coverage types is, for example, a land use coverage type. And so if I want to create a new coverage, I could just right click here and select new coverage. And that brings up this window, allows me to create a new coverage. And I can select the type when I create it. But in the land use coverage, it has polygons in the land use coverage. So let's say that I wanted to define my land use types for this watershed. Usually what I would do is just start out by drawing a polygon around the whole watershed. And the way you create an arc, so here I'm creating an arc and I want to close this arc. If I click close enough to my starting point, then WMS will snap to that starting point and it will automatically close that arc. And let's say I want a couple of land use types in this watershed, and I don't know what they are, but we're going to just create another, close this arc here. If I click close enough to this beginning point here, then WMS will snap to this arc. I also need to click close enough to this other arc to end this arc. Otherwise, it won't be connected. All the arcs need to be exactly connected. Otherwise, I do not have, things will not be, if things are not connected exactly, then WMS won't know it's connected. So like for example, if I start here and create another polygon, but then I end right here, WMS won't, even though I might intend for this to end at this arc, WMS will not know that that's connected. But I can fix that. I can just click start here and then click close enough to that arc, and then they'll be connected. Okay, one thing about polygons is I do not have any polygons yet in this layer. To get my polygons, I have to build them. And so to build my polygons, so if I select here, I just get a beep because there's no polygon. If I select this select polygon tool, to get my polygons, I just right click on this coverage, or I can go to the feature objects menu, either one, and there's this build polygon command. And it says there are no arcs selected, use all arcs. Okay. And then when I select here, I have polygons. So I have these 3 polygons. And for those polygons, I can define, in this particular type of coverage, I can define land use types. So let's say this is, I don't know, urban. And then maybe this other polygon is rural. Let's say. I don't know what they are, but let's just say that that's what it is. And you can define, then you can define your polygon attributes after you have to build the polygons though first. Okay, so the other thing I wanted to mention is so for hydrology, you have to create your streams from downstream, start at the downstream end and go upstream for your streams. For hydraulics, so HEC-RAS or SWIM, you start at the upstream end and you go downstream. Okay? So that's just a rule that you have to remember. Pardon?
I remember that before we used to use like smoothing the frame.
Uh-huh.
Smoothing the frame. I don't When we zoom in the stream, you find the pixels.
Yeah, so you're wondering about smoothing streams. Yeah, you can smooth the streams if you want. The way you do that is you just select the streams. So I'm going to select all these streams here. And you go to the Feature Objects menu, and then there's a Redistribute command. Okay. And the Redistribute command, what this will do is it will... You remember what vertices are? So your streams have nodes. Each arc has 2 nodes, right? A node at each end. But it's also going to have any number of vertices. So this command will take those vertices and it will redistribute those vertices to whatever spacing you put in here. And one of the options is to do that to a cubic spline, and that will, it just makes your streams look nice. But I think the thing that you're referring to, actually, we'll look at this other thing. So if I change this to like 500, it just changes kind of the layout of the streams. I think what you're referring to maybe is smoothing the elevations beneath the streams. Is that right?
No.
You're not.
Everything is from the hydraulic model.
For the hydraulic model?
So after delineation, if you are doing 90 by 90 EM, then your polygon, overall polygon for your area or even the streams are like
It's blocky. Okay. Get rid of the blockiness. Yeah, so this is what you use. You use the redistribute. And like this watershed boundary right here, it's kind of blocky. And if I want to make that look better, I can just select that boundary. I can select the arc that makes up that watershed boundary. Right click on it and go to redistribute. And then we'll just change it to maybe 400. Be sure you turn on this use cubic spline. And that just makes it so when I zoom in, it's going to be less blocky.
Yeah.
Okay? Is that what you're referring to? Okay. Alright, so if I read in a GIS data file, there's an option to select polygons in that and convert those to the WMS map module, convert them to a coverage. So here's a land use file. I can select polygons in that land use file and convert those to this land use coverage in the map module. Okay, so right here I have a land use coverage. You can also import CAD data and convert that to the map module. Cleaning, you can clean feature objects. So if your arc, you have intersecting arcs, if you have different problems, you need to clean up your data, you can do that in the map module. So I've kind of already demonstrated everything that you need to know. Why don't we take a little break here for 5 minutes, 5 or 10 minutes, so till maybe 11:15, and then we're gonna meet back up, and we have maybe 1 or 2 more lectures before 12 o'clock. We're just gonna keep going, okay? So let's take a break. You can look at stuff, and I'm gonna figure out WMS.